The maintenance department is extremely dependent on a properly managed stock of maintenance spares and materials. As such, the maintenance manager cannot afford not to have a proper knowledge base concerning inventory management. In this basic presentation of the characteristics of an inventory system, these 4 topics will be covered. And there we have the references from the study guide as well. First then, an introduction. The quantity and timing of purchase is one of the main issues in inventory management. It is important because if too small a quantity is purchased, the unit cost will be higher, shortages will increase, and the expediting workload will escalate. On the other hand, if too large a quantity is purchased, the result will be excess inventory and raised costs. A number of factors must be taken into account in establishing the correct quantity and timing of stock purchases. Some economic parameters, demand, the ordering cycle, how that works, and the lead time. The principle of ordering in the best quantity, called the economic order quantity, is illustrated in the following figure. Although the minimum does not occur exactly at the point where the holding cost equals the acquisition cost, this is a good position for a rule of thumb. Based on this basic model of constant rate of demand and replenishment exactly at the point that the zero stock level is reached, plus the parameters introduced 3 slides back, the following is derived. The total cost per unit times CTY equals the acquisition cost per time unit plus the holding cost per unit time. This can be written as shown. The minimum cost based on this equation occurs where the CTY dy equals 0. This gives, by solving this, we get the EOQ formula. The optimum policy is to order Y star units every Y star over beta time units. The optimum cost is then given by this formula. The EOQ formula in a nutshell. Let us look at an example from the textbook. The maintenance department uses on average 15 units per month of a certain roller bearing. The cost of processing an order has been estimated at $40, while the unit holding cost of a smaller commodity is $1.80 per month. We are interested in calculating the size of the lots which should be used for the purchase of the bearings. So the EOQ formula is then calculated as 25.8, which we could round to 26. Because 30 units is 2 months consumption, it is probably practical to purchase 30 units at a time. We calculated the total monthly cost for 30 units and that for the optimum Y star. The difference is only 52 cents per month. However, when purchasing 1 month's use at a time and 3 months' use at a time, the monthly cost is more than 15% higher than the optimum. The savings of ordering the economic order quantity over thousands of stock items can be huge. Another very practical tool in the management of maintenance stock concerns the concept of an ABC analysis. The idea is to separate the stock into different blocks, needing different stock control practices. The A items are typically a low proportion of the total volume of stock, but with a very high value. That is 80% of value, 5% of volume. The B items often represent an intermediate stock volume with an intermediate value. That is about 15% of value as an example and 15% of volume. The C items are a very large proportion of the stock volume with a very modest stock value, let's say 5% of value, 80% of volume. Example from Chase and Jacobs. The point is that you cannot give the same attention to all stock items. Those that need much attention will get too little, and those that need a very little attention will get far too much. Stock is consequently classified into three groups based on value. Firstly, the A items. Those items with high stock value, that's price times quantity, but which constitutes only a small proportion of stock items. The default stock keeping approach can possibly be to keep low or no buffer stock and use tight stock control with regular stock reviews and just-in-time stock replenishment. B items, those with medium stock purchase value and a moderately low number of stock items. The stock keeping approach can be to use normal inventory control with good records and regular attention. That is continuous review or periodic review stock keeping methods. C items, the remaining items, those with low value and high volume. Use simple controls, a simple reordering procedure like the 2-bin system. Now, what is this 2-bin system that is used for C items? It is a simple continuous review system with 2 physical bins with both initially full. When all the stock in the first bin have been depleted, an order is placed to replace them. During the wait for item replacement, items from the second bin are used. 2-bin inventory control is almost always used for small or low value items that can be easily purchased and stored in bulk. A further very simple but worthwhile stock control principle is called minimum-maximum control. Minimum-maximum control is one of the most widely used methods of inventory control. It is effected by establishing minimum and maximum inventory levels for stock items. The minimum stock level is also called the safety level of stock. This minimum level should be as low as possible. Here we see the minimum or safety or buffer level of stock, the maximum level of stock, the order quantity, possibly determined through the EOQ formula, the lead time, the time it takes for delivery after ordering, and then the order point, the stock level at which the order needs to be placed to ensure delivery when the stock reaches the minimum level. This is calculated by multiplying the lead time, say in days, by the average consumption per day. Next, we will investigate a more sophisticated stock control model.